Hello my dear students, welcome to the subject of statistics for the class 12 English medium part 1 chapter 2, the linear correlation, the second topic by Vitan sir. Today, today we will be studying about the Karl Pearson's product moment method, that is the second method of calculating correlation coefficient. The product moment method or Karl Pearson's method calculates the exact value of a correlation coefficient. We will take the pairs of observations x and y as x1, y1, x2, y2 up to n pairs, that is xn, yn. The correlation coefficient of these n pairs of observation is denoted by small r. We will call it rxy or simply r. That's enough. Its formula can be described as follows. R is equal to covariance xy upon sx into sy. Otherwise, the variance of xy divided by standard deviation of x into standard deviation of y. It's a quite simple formula. Covxy upon sx into sy. That is the combined variance of the two variables divided by individual standard deviations of the each variable. That is your formula for calculating correlation coefficient. Here, the separate formula for covariance can be explained as summation xi minus x bar yi minus y bar divided by n. That's a general formula of a variance. The standard deviation of x and standard deviation of y, that is sx and sy. We already have learned these formulas in 11th standard, the dispersion chapter. Summation xi minus x bar whole square upon n, summation yi minus y bar whole square upon n. In this formulas, the x bar and y bar could be explained as summation xi upon n and summation yi upon n. If you are noticing the I suffix in each and every formulas, we will be dropping it, ignoring it for the time being, for the sake of simplicity. I should be there, but we will ignore it for now. We will not use it anywhere. So summation xi will be just summation x, summation yi will be just summation y. We will not use I for the time being for this particular chapter. This is the main formula, but naturally we are not going to use this formula in usual sums. The usual formula which we are going to use is, after the simplification of covariance xy, sx and sy, we get something like this. Summation xi minus x bar, yi minus y bar, that's a one formula, divide by summation xi minus x bar whole square, that's another, and summation yi minus y bar whole square, that's the third one. This formula is used when the means, the averages of the variable x and y are integers and not in decimals or fractions. This is an alternate formula. Sometimes in some small questions, direct values of standard deviations are given. At that point of time, we have to follow this particular formula. Then there is another formula which has the same objective when direct values x bar is given, y bar is given, sx, sy is given. Just remember this formula perfectly. We will see its practical application in the future. I will explain at that time how to use these formulas. Right now, just note down in your notebooks these important formulas, the list. This is one of the formulas which we are going to use practically. This formula is used when values of variables x and y are very small. That means 2, 5, 12, 15, almost less than 30 we can say. Also, this formula is used when the values of x bar and y bar is not integer but in fractions, in decimals. So our x bar y bar is in decimal, so its square plus minus multiplication will also give us fractional values, which is quite complicated to calculate, and there are problems of rounding of the values. So at that point of time we will not use x bar and y bar formula, the first formula. Rather we will use the current xy formula. I have called it xy formula. The first formula is x bar y bar formula. This formula is xy formula. And then sometimes when x bar and y bar is in fraction and xy are too big, hundreds, thousands, tens of thousands, at that time we can't use xy, we can't use x bar y bar, we will use uv. So I have nicknamed this uv formula. So three formulas: the very first x bar y bar of this particular screen, then xy, and then uv. This 1, 2 and 3 formulas. This 1 x bar y bar, 2 xy, and 3 uv. These are the three most important formulas for your chapter, for your Karl Pearson's product moment method. So note it down, remember, mug it up, whatever you want. The assumption for this particular formula, Karl Pearson's correlation coefficient, the first one, that there is a linear relationship between two variables. That means the variables relationship is in a straight line. That's the very first assumption, because if we don't assume this, we will not be able to use this particular formula. So our first assumption is that the relationship between the two variables is linear. The second assumption, that there is a cause and effect relationship. Cause and effect relationship is the base of correlation. If there is no cause effect relationship, there is no correlation. So if we are calculating correlation, that means there must be a cause effect relationship between two variables. This cause effect relationship word I have explained in my previous tutorial, so refer it there for better understanding. So this is second assumption. Then comes the properties of correlation coefficient, that is the small r, the properties of the small r. This is an important theory. The first one is that the value of the small r is max to max plus 1 and minimum to minimum negative 1. That means the r always lies between negative 1 and plus 1. If your answer is more than plus 1 or less than negative 1, then you are wrong. R is always between negative 1 and positive 1. Second, it is free from any unit of measurement. It is measured not in any of the unit. It is just a number. It has no weight, height, liter, meter, kg, nothing. It is free from any unit of measurement. The third one, that correlation between x and y or y and x is same. That is, correlation between price and supply and price is same. It doesn't change because we alternate these units. It remains same. That is, rxy and ryx are same. That's the property. Remember these things properly. Correlation coefficient does not change with the change of origin and change of scale. Now change of origin means our variable x or variable y, when we add a constant value in each of the x, or when we deduct a constant value from each of the x or each of the y, that is called change of origin. That means you add or less something from our variable, that is change of origin. Change of scale is when you multiply or divide something. For example, our x is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You add 3 in all of these values, or you deduct 5 from all of these values. That is change of origin. If you multiply 2 in all these 1 to 10 values, or you divide 1 to 10 values with 2, then that is a change of scale. And when you change these things into our original data, correlation does not change. That means whether you use the original data or you make a change in the data and reuse it, the answer of correlation will be same. It will not change. That's why it is called independent of the change of origin and change of scale. This thing you will see in the UV formula. UV formula. I will explain it further at that point of time. The last one, that it is only affected by the changes in the signs. Means if you change a sign of variable x, your answer will be negative. If you change a sign of variable y, your answer will be negative. But again, if you change both the signs, your answer will be positive. Why? Negative, positive, negative, positive, negative, 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 positive. This is a basic rule we studied in the elementary standards. So just remember that properly, that if you change any of the sign of one of the variable, your answer will change the sign, but if you change sign of both the variables, your answer sign will not change. Based on this particular property, 2 mark, 3 mark questions are asked in your board, so be prepared for that. Moving on, how to interpret the answer of this correlation coefficient. Means whatever answer you get for correlation coefficient, how will we interpret it? For example, if the value of r is exact 1, we have seen the property that its answer is between positive 1 to negative 1. So what if the answer is exact plus 1, exact positive 1? If r is 1, that we can say that there is a perfect positive correlation. Positive 1, positive is positive, 1 is perfect, so that's a perfect positive correlation. We know the 5 types: perfect positive correlation, perfect negative, lack of correlation, and partial positive, partial negative correlation. So how to give those statements to these values? So if r is positive 1, it's a perfect positive. If r is negative 1, then there is a perfect negative correlation. If r is 0, then there is a no linear correlation. Mind my words, we can't say there is no relation, we just have to say there is no linear correlation. The words are very important. No linear correlation. Correlation might be there, other relation might be there, but linear correlation is not there if the r is 0. And in the events that there is a partial correlation, that is r is between 0 to 1, or it is between negative 1 to 0, that is it is either partial positive or partial negative at that time. If the value of r is positive and near to 1, if the value of r is positive and near to 1, then we call it high degree of positive correlation. What we will say? High degree of positive correlation. If the value of r is positive but near to 0, then we will call it a low degree of positive correlation. Near to 1, high degree positive correlation; near to 0, low degree positive correlation. If the value of r is negative and near to negative 1, we will call it high degree negative correlation. High degree negative correlation. And if it is a negative but near to 0, then it becomes low degree negative correlation. The low degree negative correlation. So in case of a partial correlation, there are 4 things: high degree positive correlation, low degree positive correlation, high degree negative correlation, and low degree negative correlation. So based on the value, you have to determine the analysis or the interpretation of the correlation coefficient. In the practical sums, we will understand it further properly. Moving on to the first sum which we are going to face. Illustration 5. The first illustration. Information is collected by taking a sample of 7 candidates having nearly same intellectual ability to know the effect of last day's preparation and result of the examination. So that means we have reading hours of last 3 days and marks obtained in the examination. Two variables are there for say 7 candidates, and we have to calculate correlation and then we have to interpret it. Now we will take reading hours as the x. We will consider it x, and marks as the y. We will consider marks obtained as y. The formula which we are going to use here is the first one, the x bar y bar formula. That is summation x minus x bar y minus y bar summation x minus x bar whole square whole root into summation y minus y bar whole square whole root. Remember the formulas I told you guys, make a list, mug them up. Don't forget the formulas. If you forget the formulas, there is nothing you can do in this chapter, and if you can remember the formulas perfectly, there is nothing in this chapter which can create a problem for you. So moving on to the answer slide. First, write down the data as reading hours as x and marks as y. Copy the data perfectly. If you make a mistake in copying the data, no one can save you. Make a total. Once you make a total, find out the averages. The x bar will be 231 divided by 7 as 33. The integer value, I told you guys, if both x bar y bar are integer, use x bar y bar method. Y bar is also 72, that is integer. So 33, 72 integers are there. We will use the x bar y bar method. Now from the question you can see we have to create these columns. The first column will be x minus x bar, that is from the whole x column you have to deduct the value of x bar, that is 33. Y minus y bar, that is from the y column you have to deduct 72. X minus x bar into y minus y bar, that is the multiplication of the first two columns, x minus x bar column and y minus y bar column. X minus x bar square is the squaring of the x minus x bar column. Y minus y bar square is the squaring of y minus y bar column. We will start with the very first column, x minus x bar. Value of x is 25. The mean is 33. 25 minus 33 is minus 8. Second value is 38. X bar is 33. 38 minus 33 is 5. Then comes 30 minus 33, negative 3. 28 minus 33, negative 5. 34 minus 33, 1. 40 minus 33, 7. 36 minus 33, 3. That means from the whole of the x column, I deducted the value 33 each and every time. And this is the column which we get. Similarly, from the column of y marks, we will deduct the value 72 each and every time. And your answer will be something like this. That means you have to deduct all the values of y with 72. That is the mean of the y. Remember one thing, in this method, the total of the columns x minus x bar and y minus y bar should always be 0. If this answer is not 0, you have made some mistake. This answer must be 0. That's a fundamental rule. You have been taught this rule in the 11th, that total of the x minus x bar and y minus y bar should always be 0. If you don't remember, don't worry. You just remember it right now. Moving on, we will make a multiplication of the both new columns and you will get the answer like this. Don't make a mistake in multiplying the signs. For example, negative 8 into negative 7 is positive. 5 3s are 15. Negative 3 into negative 4 is positive. Negative 5 into negative 2 is positive. Rest is according to the sign. Plus plus plus, minus minus plus, plus minus minus, and minus plus minus. Don't forget the signs. Now for these two columns, x minus x bar, y minus y bar, find their squares. Easy task. 8 8s are 64, 5 5s are 25, 3 3s are 9, 5 5s are 25, and so on. Once you are done with these three columns, make a total. Once you are done with the total, start with the actual sum. Give the title, Karl Pearson's product moment method. Write down the formula. R is equal to summation x minus x bar y minus y bar divided by summation x minus x bar whole square root into y minus y bar whole square root. Put the necessary values. You have found the total, put the values. Now the first next step will be multiplying the values in the square roots. That way you will get a combined value of a square root, that is 24752. Once you get that combined value, find the square root, and once you get the square root, divide it. This is your answer. R is 0.96. Now two things are very important. First of all, this is a positive value. Second one, it is very near to 1. So we can set the value of R is very near to positive 1, and therefore there is a high degree of positive correlation between the reading R's and the marks. That is positive value near to 1, so high degree of positive correlation. My dear friends, this is a first sum, and this is how you are supposed to find the value of correlation. That means the more number of reading hours you have before the examination, the more number of marks you will score, and there is a very high chance of this happening. Moving on to the next illustration. Illustration 6. You have marks in Gujarati and marks in statistics of some students of a school. The marks in Gujarati is supposed to be denoted by X, statistics is to be denoted by Y. Find the correlation and interpret the data. That means we have to check whether the marks in Gujarati and marks in statistics are related with each other or not. That means whether Gujarati is high mark denote high marks in statistics, or Gujarati is high mark denote low mark in statistics. We have to decide that. First of all, we need to make a total. This is always the first step. Make a total of both the rows or columns. That is, make a total of x, make a total of y, and find the mean. Why? Because the mean decides which method you are going to use. Here the mean is integer. Both of the means, as you can see, are in integers, and because they are in integers, our regular x bar y bar formula will be used in this sum. For that, we will copy the data, make a total, put our necessary columns into order. The first column x minus x bar, our x bar we know what it was in the previous slide. We will deduct each value with that particular x bar. Y bar from the previous slide, from the y column we will deduct all the values of y bar. The y bar is 90 here, the x bar was 69. So x is deducted with 69, then y is deducted with 90 for each and every value. The total is 100. My mistake. The total is 0 for both the columns, and x minus x bar, y minus y bar is the multiplication of all the columns, the two columns which we created here. The x minus x bar whole square, that is the x minus x bar column square. Of course squares will be positive, my dear friends, don't make a mistake in that. Y minus y bar whole square, that is y minus y bar columns square. And once you are done with all these three columns, make a total. Once you are done with the total, write down the formula x minus x bar, y minus y bar, put the necessary values. After putting the values, multiply the root, make a root, divide, and you get your answer. R is 0.16. First of all, it is a positive. Second, it is very much near to 0. Now in case you are wondering where is this boundary line, whether it is near to 1 or near to 0, then the boundary line is 0.5, the half. If it is more than half, more than 0.5, it is near to 1. If it is less than half, less than 0.5, then it is near to 0. Naturally, my dear friends, 0.16 is less than 0.50, so it is near to 0. Therefore, R is close to 0 and there is a low degree of positive correlation. Low degree of correlation means that marks of Gujarati and marks of statistics are very loosely related. If we think logically, Gujarati is a language while statistics is a calculative subject. It is not necessary that people who are good in languages will be good in calculative subjects. Mostly it is the opposite thing. But still it shows a loosely, very low degree of positive correlation between the two subjects. So this kind of analytical things we can say from calculating this measure. Moving on to the next illustration, illustration 7, the details of monthly sale of mobile phones and the profit. Naturally, we know that more number of mobiles you sell, the more profit you earn. But how much? That exact value we need here. If you take the averages first, as we have to, x bar is 6.67 and y bar is 9.67. My dear friends, this is not integer, this is a fraction, the decimal value. And I told you guys that when the means, the averages are not in integers but in fractions, the decimal values, we must not use the x bar y bar method. The remaining two methods, the xy method, the uv method. Now xy method when the question values are small, uv method when the question values are big. 3, 8, 12, 5, 7, 5. Does this seem as small? Yes, these are small values. And because these are small values, we are going to use the xy method. The R is equal to n summation xy minus summation x summation y, n summation x square minus summation x the whole square, n summation y square minus summation y the whole square. Now my dear friends, don't worry, any formula you use from the list I have given you guys, the answer will be same. answer will not change. If you use here x bar y bar method, you will get the same perfect answer till the decimals also. But why am I suggesting you a different method? The logic here is it becomes easy to calculate when you use the respective method. If you use x bar y bar here, the 6.67 will be deducted from all the x's, then it will be multiplied with another decimal value method, then it will be squared, then you have to divide them, root them. All of these things are quite tedious and it can become erroneous. You can make many errors in the calculation and rounding of the decimal points. To avoid all these things, we are using simple xy method. In xy method, you will be creating something like this. First of all, the x, the y, make a total. This time you just need three columns. X and y columns are already available from the question. You have to just multiply them into xy, then x square, y square. If you check out this, if you compare this formula with our x bar y bar formula, you will see a quite similarity. X minus x bar, y minus y bar, multiplication of the two and individual squares of the two. Here x, y, multiplication of the two and individual squares of the two, means it follows the same exact pattern only with different values. We will start with the multiplication of the two values, that is x and y. 6 3s are 18 and 8 10s are 80, 12 15s are 180 and 5 10s are 50 and so on. We will be squaring the x column, we will be squaring the y column, and once we are done with the squares, we will total all the three columns. Once we have got the total of all the five columns, start by writing down the formula. This one is a bit longer than the before, but this is important. Remember this well. A mistake of a single symbol can cost you your 5 marks. This is a 5 marks chapter. N summation xy minus summation x summation y divided by n summation x square minus summation x the whole square whole root into n summation y square minus summation y whole square whole root. Put the respective values. Now n is 6, the total of xy column is 431, the total of x column, the total of y column, that is 40 into 58, divide by under the root. N is 6, summation x square is the total of the x square column, that is 316, minus summation x. Now this is not summation x square, this is summation x the whole square. It means different than the summation x square. In summation x brackets square means you have to write the value of the total of x column, that is 40, and then make a square of it and not write 316 directly. That means n summation x square minus summation x the whole square is 6 into 316 minus 40 whole square. Then moving on to the y group, n summation y square is 6 into 606. 606 is the total of the y square column, minus 58 square. 58 is the total of y column. So don't make a mistake here. If you make a mistake here, which so many students have been making continuously and losing marks in the boards, you will lose marks in the boards. Once you have written all the values perfectly, make necessary multiplications. 6 into 431 is 2586, 40 into 58 is 2320, 6 into 316 is 1896, 40 square is 1600 whole root, 6 into 606 is 3636, 58 square is 3364 whole root. Once you are done with this, you have three sets of values for you, which you have to make some deductions. After deducting, you will get three values. Once you are done with these three values, first of all, in the denominator, make a multiplication between these two root values. That way you will get a single root value 80512. Make a root. Once you are done with the root, divide, and that way your answer is R. There is a correlation coefficient 0.94. Our statement will be that R is near to positive 1 because it is near to positive 1, it is higher degree of positive correlation. So naturally, if you sell more number of mobile phones, you will get more number of profits. That's a very simple logic. So moving on with the same logic, discuss some theories. Three sums are already done of this method. Let us discuss the theory of this method now. The merit of the Karl-Pearson's method that it doesn't only give us the degree but type, degree and type both can be known. The type that is positive, negative, and degree that is high degree or low degree, we can know both the things. The second is that it is the most popular method. The third, that it summarizes all the characteristics of a correlation in a single digit, 0.95 and we get it, zero point 0.1 and we get it, negative 0.7 and we get it. So in a single digit, we can get the whole idea of the data in the matter of correlation. The limitation, the first one, it depends on assumption, and whenever there are assumptions, there are always limitations. The first assumption was that there should be a linear relationship. It is not always possible. The second assumption was quite misleading, and therefore our answers cannot be possible. So assumptions which we have done for correlation are not practical and they are misleading. That's why our answers sometimes becomes misleading. The value of correlation coefficient is affected by too big or too small observations. Now, even in our 11th, the mean was affected by too big or too small observations. So, same type of limitation also affects our correlation coefficient. The last limitation, that at the time of interpretation, if we don't take proper care, we can misunderstand the relationship between the two variables. It could be either due to our assumption or the lack of information or the lack of experience or just laziness at our part. But if we make a wrong interpretation at any turn, it can create misunderstandings. So apart from three merits, the three limitations are quite severe. So we have to take very high level of care while using this measure. But you are just students, so don't worry much about that. Just do your work. When you grow up and become statisticians, at that time you will be thinking about these things. Right now, just remember this as a theory, nothing much. Moving on, I'm giving you two sums for your homework, which you have to do on your own. The first question is the minimum temperature and the demand of heaters. As usually our temperature drops, we demand more heaters, and our temperature rises, we demand less number of heaters. Now, you have to check the data out. First of all, make a total, calculate the mean. If both the averages are integers, mind my words, if both the averages are integers, use x bar y bar method. In case of any doubts, revert back to the previous sums which I have done in this video. If both or any one of the averages are fractions or decimals, use xy method because the values are small. Use xy method. But if the averages are in integer, use x bar y bar. If they are in fraction, use xy method. The second question is illustration 13. Now in this question they have directly given us x minus x bar, y minus y bar is given, x minus x bar square is given, y minus y bar square is given. What you have to do? Put them in the formula, get the answer, done. No tables, nothing. You are not supposed to do anything extra. The values are given directly. So I am hoping that with these two sums and the three illustrations which I have done in this video, I will be ending this tutorial right now. I have explained you the Karl-Pearson's product moment method, its formulas, assumptions, properties, merits, limitations, x bar y bar method, xy method. In the next tutorial, I will be discussing the UV method and some other sums, some illustrations of this particular topic. See you then. Study properly.